just yell, I can't hear you, and I'll do my best to ignore it. Okay, good. Okay, so my name is Ryan Horton. Just a few notes for this talk before we get started. If you're going to tweet about this, please put pound flourish on it. It shows up on that projector out there, so don't be rude. But you know, we love feedback from people. We love feedback in real time. So positive and negative things. If you think I said something stupid, tweet about it. I'll cry to myself later on. Feel free to interrupt me if you have a question or a concern or just didn't hear me or something. Just yell out, and I'll, you know, it might change the whole contents of my talk, and it might be more interesting. So feel free to interrupt if you need to. The slides for this and all sorts of other things, big link dump of everything I talked about will be in that address up there. That's iculus.org/flourish. Okay, so who am I? A game developer. I port software and games specifically to other platforms. I think of myself as a hacker in a positive term. I port video games, and when I'm not porting video games, I build tools to help port video games. If you want to look me up, I'm at Iculus on Twitter. That's my email address. That's my resume. I got my start with video games at a company called Koki, who did nothing but port video games to Linux up until they went out of business and we all desperately struggled to find new jobs. From there, since then, I've been a freelance contractor. I worked for a bunch of different game companies. Some of them you haven't heard of but are awesome and you should. And some of them are big name ones you might have heard of, like Activision or Electronic Arts or Epic Games or Google. But I should say though that I haven't slept in 2 months because I have an 8-week-old baby at home. So really, my most demanding client right now is this person right here. Anyway, okay. So tonight we're going to talk about open source tools, and if you're a game developer, these are things you should be using in your projects. Even if you're only developing for Windows, you can still get a huge benefit. Generally, I talk about Linux game development, but this applies to any platform. I try to pick things that weren't specialized to 1 or 2 platforms. So this is going to talk about, let's work on the PlayStation 3 and also the Xbox 360. These are all things that you can download and use and build games off of today. Just as a disclaimer, though, this is not a complete list. There's lots of things I'm going to gloss over. There's even more I'm not going to talk about at all, and I'm probably still going to run over my time. So if you think there's something important I don't mention, please bring it up. Okay, so let's get right down to it. The first thing I want to talk about is SDL. SDL stands for Simple Direct Media Layer. This is something that everyone should be using if you're writing games on Linux or Mac OS. If you're a Windows person, there's a little bit of an attitude towards using this because it's like, well, we can always just use the Win32 API, and that's always fun. But what Simple Direct Media Layer does is when they first started working on this in the late 90s, what they were thinking was answer to DirectX. So it was a lot of things like, here's how we get video onto the screen, and here's how we play audio through the sound card, and how we control joysticks, and some other plumbing things so that you don't have to worry about how to spin a thread, how it's different between different platforms and stuff like that, and timers and stuff like that. Simple Direct Media Layer, the current stable version is version 1.2. 15, but the 1.2 branch is a stable one right now. And as a piece of understatement, I say it runs on a lot of platforms. This thing runs on everything. If you have a game that you built all your low-level stuff on top of SDL, it probably runs on systems you've never heard of. You can probably take it and get a compiler for the Dreamcast and run your game on the Dreamcast. There is a Dreamcast port of SDL. I'm not kidding about that. Other things, BIOS, Amiga OS, the toaster in your house, whatever. People think of these things as, Linux, Mac OS, or Windows, but there are other desktop systems it runs on, and there's embedded systems it runs on, and blah-de-blah-de-blah-de like that. It's very easy to use. That's the website. I'll have that link along with all the other ones up on my website later for you. But I want to give you an example of why we call this Simple Direct Media Layer, because we're very focused on that word simple, the S in SDL. To illustrate this, I'll give you a simple Direct 3D example. Has anyone in here done any Direct 3D programming? There's that one poor guy in the front. I'm so sorry. We can get you a job somewhere else. It's okay. Okay. So I'll give you, I have some code up here. I'll just run you through this really quickly. This is how you get a 640 by 480 full screen Direct 3D context so that you can draw into it. You can set up the window and get it on your screen and stuff like that. So here you go. This is, let's see here. This is, if I get my, there it is, okay. So, up here you got to create a window class, and then you make your window based on that window class you registered, and then you update it, and that just gets you a window on the screen. That's good. And then from here you can go on and, let's see, what is that? Oh, then you got to enumerate your adapters to see if you have one with the right resolution, and then you have to make sure that you can do vertex shaders, or hardware accelerated stuff. And then after that, on this page, we're doing oh, you have to check to see if there's 16-bit Z buffers, and then over here you can actually create your device, and then you can start pretending you're ready to set up state to draw. Okay, so that's easy. That's very simple. I'm sure you've all copied this down at this point. This example was not actually the one that comes with the DirectX tutorial, but it looks about the same as what Microsoft tells you to do. Just so you understand, I'm not blowing this out of proportion. This is actually the code you would use. Except for one thing that you shouldn't do, which if you could read this on the screen, you might see this a lot. This comment is in every line of that. There's no actual error checking in this anywhere. So that code example should be much, much bigger than it is. So, okay, that's fine. That's the easy way to do things. Now we're going to take the really complex way with Simple Direct Media Layer, just to show you that's much, much harder with the open source tools that are available to you. All right, you ready? There you go. So you'll note this also doesn't have error handling. So I'm sorry, but for the 2 lines, you can add your own. It's pretty straightforward to it. So. Okay, so like I said, the current version is SDL 1.2, and the things that SDL 1.2 is focused on is, I'm going to just be fair about this, we started working on this in the 90s, so there's a lot of early 2000 games that came out that dictated the functionality that SDL needed to have so that we could get those games running on Linux, because a lot of this software was written by Loki Games because they needed specifically to port stuff to Linux. So the first game they ported was Civilization Call to Power, which is a 2D game. It only wants to write pixels into a frame buffer and then get that frame buffer to the screen. So the original versions of SDL, 0.9, whatever, did just 2D video. Here's how you draw pixels. Here's how you flip it over the X server to the screen. And then Heavy Gear 2, I think it's called, came out, which is a 3D game, used OpenGL, and we needed to extend SDL for that. So then you got this flag over here, that SDL _ OpenGL, that, things were extended like that. And even in this day and age, SDL 1.2 has held up pretty well. It's 95% of the things you would need to make even a modern game. In fact, games as new as Doom 3, actually, well, not Doom 3, but Prey, which was based on Doom 3, used SDL 1.2 and didn't really have any problems doing that. You needed to get an OpenGL context on the screen, it needed to get input from the user, it needed to play sound, no problem, done. So this still mostly works, and you can get, it has all the things you would need for low-level game development stuff, like, events, when the mouse has been moved, or, when a joystick has been pushed or something like that, and timers, how many milliseconds have elapsed since I last did something, joysticks, I just mentioned, and things like loading libraries, like so you don't have to write, if def Windows call load library, if def Linux call DL open. It handles all that stuff behind the screen, behind the scenes, and wraps it in a nice simple API that's like, this is what I want to do, don't mess around, just give me what I need, okay, we're cool, bro. So yes, that's good. But we can't rest on our laurels, so we're currently working on SDL 2.0, which up until recently we were calling 1.3. The primary things about this is that it removes limitations and it modernizes things. For example, we've chopped out a lot of those old platforms, and if someone comes in with a Dreamcast port, we'll accept the patches, but we decided that there's a lot of legacy code that nobody really cares about running this on your Palm Pilot 3 anymore. So, we've pulled a lot of that out. Like OS2, I'm sorry you lost, but if an OS2 maintainer wants to step up, we'll take their patches in, it's no problem. But in modernizing that, we kept the platforms we thought were important just for the base, which was Linux, Mac OS, and Windows, and various variants on that. But more importantly, we added Android and iOS support, because I have a feeling that's where a lot of us are going to be writing our games in the future, or if nothing else, it's a place we're going to be porting our games in the future. So we tried to make the API work consistently across all those platforms. And this is all a work in progress, but you can try it now and it works on all those platforms. And there's still bugs, there's still things we're filling in, but a lot of the things were, okay, this worked nicely in SDL 1.2, but we want to make it better. Like for example, in SDL 1.2, my nice example there, set this video mode, you can only have one window. And we've changed that so you can have as many windows as you want in SDL 2.0, and you can have as many audio devices as you want. So you can play your sound through the speakers, and if the guy has a USB headset plugged in too, you can have your voice over IP go over that, as totally separate devices, or something awesome like that, or do multi-mouse games, which are awesome, and stuff like that. So that's in progress. We're still working on it. We think it's cool. We hope you try it. Lots and lots of games have been built on SDL, and lots more will be built in the future. It's kind of the gold standard on Linux for game development, and it's quickly becoming so on other platforms too. So moving on from SDL though, I want to talk about OpenAL for a while. OpenAL is a 3D positional audio library. It was Loki's original answer to DirectSound 3D. which was important, again, in the early 2000s. And they got Creative Labs on board for this, which for those that maybe owned a Sound Blaster at some point, can I get some what up for Creative Labs? Okay, good. They all came on, they built this API, and if you've ever used OpenGL, OpenAL is named as such because it feels a lot like using OpenGL. It's, I'll get into the details of that in a moment, but it's cross-platform, it runs on lots and lots of things, it's very easy to use. I'm not going to give you the Direct Sound 3D example, but it looks a lot like the Direct 3D one. But you know, while we're at it, I'll give you the OpenAL example. You know, so this is, you know, the bolded things are the three functions you really care about. You open a device like a sound card, or you know, a network server or whatever, but a sound card, we'll say. You create a context on it, you make it current, and then you can play sound on it. That's it. And you'll notice that this one actually has error handling in it, so you know, good for me. Anyway, the way OpenAL works is much like OpenGL. It's a stateful system. So, like, if you're an OpenGL user, you think of objects a lot, like textures and vertex buffers and you know, things like that. And then you set state on those things, like, you know, should there be MIP mapping on this texture and stuff like that. But your objects are, it's a much simpler set of objects in OpenAL. You have one listener, which is, you can think of it as a microphone, you can think of it as an ear. It's whatever, it's where the world is listening from, and that will be what, in relation to that, is where things play through the speakers. You have a handful of sources, which are things that are making noise, and then you have lots and lots of buffers, which are wave files, for lack of a better term. It's PCM data. And you attach a buffer to a source and you play it, and you move that source around in a 3D space around the listener, and OpenAL figures out how that should shift between speakers. And you know, most people only have a stereo setup, but a good OpenAL implementation, there's no limits that say it can't handle speakers all around you and above you and below you, at least in theory on the API. And the last object is buffer queues, where you can say, I need to stream audio, like I have, you know, a voice over IP or some internet radio station, and data's coming in, you can just keep handing it to the source as it's coming in without having to keep going back and tap dancing with it. You just keep streaming it in there. So it's very, very easy to use, very pleasant to use. Chances are you already have a system that has OpenAL on it. If you're using a Linux box, you might have OpenAL installed already on it. If you're using a Mac, it's installed by default as of macOS 10.4. If you have an iPhone, OpenAL is the primary way for games to make noise on iOS. So you're guaranteed to have it on those platforms. Windows has freely downloadable ones. If you've ever played some games off of Steam, you notice it does an OpenAL installer before you actually get to launch your game. I see, Linux, Mac, I think it's pretty sure. Chances are, if you don't have it, you can ship it with your software, but lots of platforms are starting to ship with it included. So it's a huge win, and it's really easy to use and kind of fun to use, too. So, and it's worth noting that I've started using this thing with 2D games, too. We just shipped a game called Avedon for the Humble Bundle that's running right now, which, by the way, you still have a day and a half left if you want to buy it for any price you want. I won't get into the pimping match here, though. We used OpenAL for it because it was the simplest way to get audio running in the game. Porting the thing from Direct Sound to OpenAL took about 20 minutes, and the OpenAL implementation is 115 lines of C code. So dirt simple to get in there and make noise, which is awesome. I love that. Anyway, enough about audio for now. Let's talk about SQLite. Does anyone here use SQLite? Every one of you that has a computer in your pocket right now has a copy of SQLite. Every single one of you. It ships on Androids by default. It ships on iPhones by default, it ships on Macs by default, Linux by default. If you're using Firefox, if you're using Google Chrome, if you're using Safari, you have a copy of SQLite on your system. It is literally ubiquitous. It is almost impossible to get a computer in 2012 that doesn't have a copy of SQLite on it somewhere. It's awesome. Now, people go, well, this is a game development talk. Why are you talking about SQLite? So, for those that don't know, SQLite is an SQL engine. You give it commands like select and insert, and it does database stuff, but it does it to a single flat file in your wherever you want. You don't need a network connection, you don't need a database server, it's just flat files. SQLite is one single C file that you drop into your program. You don't have to worry about shared libraries and dependencies. You just copy the C file into your project and start using it. And again, you're already using it. You probably have some software on you right now that's using it. It's worth noting, though, because people talk about, well, why do I need a database? And my argument is, if you're ever writing a flat file, like a config file, or some sort of basic data file that doesn't have a structure otherwise, you probably should be using SQLite on it. Specifically, D. Richard Hipp, the guy who writes SQLite, has been quoted saying this, that it doesn't compete with Oracle, it competes with fopen. Because chances are when you're writing that very simple comma-separated value parser or that very simple INI parser, you're inserting bugs, especially if you're doing it in C, because string handling in C is hard. It's much easier if you can just simply open a file and say select this from this field, go, and it works. And again, if you're a game developer, it's very, very easy to embed this. Just drop it into your project and go. So that's cool. You should definitely be using that and find some interesting use for it. There's lots of things. All right, so let's talk about, while we're talking about files, let's talk about PhysicsFS. Oh, hang on, pimp alert. So I wrote this project called PhysicsFS. It's awesome. What it is a virtual file system. You give it, this was inspired, I did some work at one point on Quake 3 Arena, and they have a method sort of like this built into the game, where you basically give it a bunch of zip files and CD-ROMs that are mounted and the game's base directory and some separate directory over here which is user-specific stuff. Your save games are over there. And they basically push it all into one big file tree. And more importantly, and it all looks like, if there's two zip files that have the same file, the later one wins. You lose access to the older one. And what's really useful about that is that whenever id Software pushed an update to Quake 3 Arena, they just put out another zip file. They never patched anything. They just gave you a new zip file with the changed files. And those files would immediately override the previous ones. There, you're up to date. You never have to go and edit something, make sure the checksums are right. It's pretty awesome. So I wanted other games to be able to do that, so I built my own from scratch called PhysicsFS, and it has zip file support, and if you're old school, it has support for Doom WAD files and Quake 1 pack files and build engine group files, which is, I guess if you're Duke 3D, that's really useful. But you can put all these into a virtual tree. You can mount them wherever you want in that virtual tree, much like you might mount a virtual directory in your Linux file system. And it's cool. And there's a game that shipped a couple months ago called Dungeons of Dreadmore. I don't know if anyone's played it. It's a roguelike. It's pretty cool. The night before they shipped, they realized they wanted to add mods to the game. They wanted people to be able to build their own mods to the game. And no one thought about this until literally when they were shipping. So they dropped PhysicsFS in it overnight. And now you can drop mods into a separate directory. Every zip file will override specific parts of the game to let you mod it however you like. Total time spent on that was a couple hours, and they did it without even reading the documentation. Their documentation was pinging me by IM, every 20 minutes or so, and it didn't take them very long. So, but it's PhysicsFS is concerned with security. You get one write directory, and you're not allowed to write outside of it. If a user if you have some mod that wants to write to .. .. try to get down further in there, it won't allow that. It rejects those. If you try to read through a symbolic link and you don't give it permission to read symbolic links, it'll cancel the file operation so that people can't be sneaky if you don't want them to be. So theoretically, you could build some kind of web browser widget thing that you can trust outside code because it can't get out of this one directory, as long as it's always writing through the PhysicsFS API. And it's flexible. We've just added an abstract way to add your own I/O method. So if you want to have a zip file that's actually not a zip file at all, it's just a piece of memory that you're faking it as you go along, you can do that, and it's pretty cool. Anyway, so look, I know that PhysicsFS has nothing to do with physics, and I apologize for that. I get an email about once every 6 months saying, "Why'd you call it that?" It was part of a game engine that failed. I was writing a game engine that was supposed to be like The Incredible Machine, but with more physics in it, and so it was the only part that was worthwhile out of there, so we ripped it out and made it open source. But everyone's confused. Why is it called PhysicsFS? But so there you go. Anyway, but enough about that. What about actual physics? I have two things listed here, and I know nothing about them, but I leave them here in case you want to Google for it. Open Dynamics Engine and Box2D. Open Dynamics Engine has been kind of a mainstay for a while. Box2D is a newer entry into this. The only thing I know about is that Angry Birds uses it, which suggests that it probably works pretty well across many devices. You'll have to Google for more. It's just something I haven't worked with directly in any significant matter. Anyway, let's talk about audio for a while here. Everyone needs to play music and sound in their games. So there's a library called Ogg-Vorbis, and there's a library called Speaks. Ogg-Vorbis is named after a character in Terry Pratchett's Small Gods novel, in case anyone was wondering where that weird name came from. And ogging is apparently a geek term for doing something with brute force. Not necessarily the best recommendation for the library, but it's worth using. Okay, so the gist of this is that
you want to use Ogg Vorbis for your regular stuff. Anywhere that you're making a game and you're thinking, I have a problem, I have a problem that I need to play audio, so I'll just put some MP3s in there. Now you have two problems. So the second problem is specifically called Fraunhofer, which is or however you pronounce that, which is a German company that owns the patent on MP3s and are happy to sue people that don't pay to use MP3 technology. So every time you buy an iPod or an iPhone, Apple pays them a quarter. And then, they keep a 40% markup, and you can be mad at Apple about that. But for everything that plays MP3s legally, you pay 25 cents or something like that to this organization in Germany for patent licensing. In fact, I've actually known video games that have licensed a library called the Miles Sound System, not because they wanted to use it for their sound, but because you get an MP3 patent with it. And it's cheaper than paying for every copy that sells, which is just a state of insanity. You shouldn't ever get into business deals like that. Ogg Vorbis is roughly comparable. Thank you. Ogg Vorbis is roughly comparable to MP3 in technology. The quality's about the same, the compression's about the same. Most notably, it's not patent encumbered. You can use it for free, it's BSD licensed, you can drop into any program and not have to open up your source code, whatever, So it's cool, and you should be using that, you shouldn't be using MP3s. It's really just that simple, especially if you control the entire data set of your game. And if you're a modder and you want people to be able to put their own audio into it, there's lots of free available tools for Ogg Vorbis. They're not as ubiquitous as MP3, but they're very, very ubiquitous. There's Speaks is the other end of that scale. It's low quality audio, specifically voice over IP. In fact, there are voice over IP products that are using Speaks. Unreal Tournament 2004, their voice over IP uses Speaks. There's phone box things that use Speaks. IO Quake 3, which I'll talk about briefly later, we dropped Speaks into there. And to give you an idea of how little bandwidth Speaks needs to be able to do voice, we stuck it at the end of a network packet, just like here's game state that's going across the wire, and we just need a few bytes at the end for audio data in Speaks. It's that low bandwidth. It's incredibly good. You can be on a 28.8 dial-up modem using Speaks and do full duplex discussion. It's that low bandwidth. It's really, really nice. So it's also patent unencumbered, and it's also BSD licensed. You can just drop it in there. All this stuff is at ziff.org, which is, I think, some kind of fish. I don't know what Ziff is. However, here's a pro tip for you. Don't use libvorbis. I know, I just told you to use libvorbis. I'm sorry about that. Ogg Vorbis ships with libvorbis, which is their low-level API. They also have something that ships in the same package, in the same zip file with it, called libvorbis file. And that makes it the equivalent of my Direct3D example versus SDL. Libvorbis file is dirt simple to use. Here's my data, give me back uncompressed audio. Nothing fancy, you don't have to worry about trying to sync up sound frames and stuff like that. It's just, here's data, give me data back. So always use libvorbis file, it's much easier to use. All right, so while we're talking about things that have the word Ogg in front of them, I want to talk about Ogg Theora for a moment. Ogg Theora is a video codec in the same way that Ogg Vorbis is an audio codec. Does anyone know where this name comes from? Anyone remember this guy? Theora was a character on Max Headroom. So, and also I just really wanted to put that in my slides. So, okay, so Ogg Theora. It's the video equivalent of Ogg Vorbis. In fact, if you do an Ogg Theora file, the audio will probably be Vorbis, but the video will be this format here. It was originally based on something from a company called On2. They had a codec called VP3, and they donated this codec to ziff.org and said, we'll waive all our patent rights on it. It's not patent encumbered, and the ones we have will waive so you can use it as Ogg Theora for free without bothering anyone, without signing anything. It's very good. It's not, I'm going to tell you right now, it's not the best video codec in the world because, video codecs are actually a very competitive field right now, and you're seeing things like WebM and H.264 or whatever it's called and stuff like that. So competition will always push forward. The Theora format, it's pretty good. It's not the best, but we're actually talking about kilobytes now instead of megabytes. And it can do high quality video. It can do HD level video at full speed reasonably. So, and also you don't have to pay for it. Also, it's fairly simple to embed in a project. So these things matter when you're a game developer. So it's worth using. However, I have a pro tip for you too. There is no libvorbis file for this. You have to get down and dirty with this thing at the low level and worry about where frames are syncing up and whether the container format is in the right order, and it's awful. So more blatant self-promotion for you. I have something called Theora Play I've written, which wraps this in very simple API, and it can do all the decoding on a separate thread, so you can take advantage of multi-CPU things. So, and it's just a wrapper around Augtheora, so you're still using the same technology. You just don't hate your life while you're working with it, I hope. So that's that. Enough about this. Open this. Dying of thirst up here. There we go. Oops. Okay. Messy. Enough about that. Let's talk about scripting languages for a moment. Who's used Lua? Holy crap, a lot of you. Okay, good. You can all go home. You already know my whole speech. Okay. Lua is awesome. Chances are, if you've played video games, commercial video games, you've probably played something that uses Lua, even if you didn't know about it. How many of you have played World of Warcraft? Are you kidding me? Seriously? Is it past that time? World of Warcraft does all their scripting in Lua, and opens it up to the end user, so you can mod World of Warcraft using Lua. You have a question? That's to add a sense of danger to this. I'll put it down here so I can accidentally kick it in a moment. It's the gallery. I'm going to smash a watermelon up here too later, so I hope you all brought ponchos. Okay, so Lua. Yeah, okay, so as far as scripting languages goes, raise your hand if you're a programmer, or went to my programming course earlier, so you're now a programmer. Okay, good. Lua is very simple to use. There's lots and lots of scripting languages out there. Lua excels in one way that's really nicely. Everything is based on tables. So if you take JavaScript and you take all the shitty parts out of JavaScript, you kind of have Lua. Unlike JavaScript, though, it's really fast. In fact, when Google started working on the V8 engine, which is Google Chrome's JavaScript engine, the people who built that cited Lua as one of their influences for how to speed up JavaScript, because they've just done some really smart things behind the scenes and under the hood in Lua itself. It's very, very easy to use. It's not C-like. If I had to describe it as a language, it's a lot more like QuickBasic, which I'm sure is making everyone run for the hills. But keep in mind, when you're scripting, you don't want clean and elegant. You want fast and easy to iterate. Clean and elegant you can do in your C++ code in the engine itself. But in your game scripting, you want to actually just make it easy to make changes and easy to write complicated things quickly. So just it's important to make that distinction. A lot of people have to make that mistake once before they understand that's a mistake. But I'm trying to warn you now. If you write a game, push as much of it into a scripting language as you can right from the start. It's very powerful. Everything's based on tables. If you're a JavaScript programmer, you know that you can take an object and assign random properties to it, and you can just have arrays with like strings for their index and stuff like that. That's how Lua works. It's much like that, and that gives you a lot of really cool features that aren't available to more statically typed languages and stuff. It's very, very easy to embed. It's a couple of C files. It's written literally in ANSI C, and I know everyone shrugs at that, but literally it's ANSI C. Like you can compile it as ANSI and it will work. And they have some small extensions if you want Linux-specific features or macOS-specific features. But the base interpreter itself is all ANSI C. You can drop it into your program and just go. And unlike most scripting languages, and this is a very big important thing, this is part of why Lua has been very popular with game developers, very easy to jump back and forth between Lua and C or C++. So you can do all your game logic there, call a function in Lua that brings you right into a C function that does something that needs more performance, and then jump right back into Lua from there and do callbacks between the two and stuff. It's pretty cool, and it makes for just some very powerful things. It's popular in current AAA titles. Crytek uses it in the Crysis engine. World of Warcraft uses it. Lots and lots of other things. I keep stumbling upon .lua files in games. So that's at lua.org. You should definitely check it out. It's pretty cool. Okay, I want to talk about these really quickly because these are the things everyone thinks about when they think of open source game development libraries. zlib, libpng, and libjpeg. Does anyone recognize these names? Okay, good. Everyone recognizes zlib, I think, if they don't recognize the others, because you probably used it in some form even if you're not a game developer. Zlib is a compression thing. If you've ever used a zip file, that's the compression format. Zlib handles that. That's the type of compression it uses. libpng is a lossless image format, and JPEG is a lossy image format. I'm not telling you anything you don't know. These are old libraries. They've been around for a long time. They've been carefully maintained and debugged and ported, and I'm just going to give you a pro tip and tell you not to use any of these libraries. because they're hard to use, and I'll tell you exactly why. zlib has an enormous amount of baggage on it because it still runs on like DOS and Mac OS 7 and 6 and stuff like that. It works well enough, it's no big deal, but there's a lot of bulk in that package that doesn't need to be there. libpng, depending on how you compile it, you become binary incompatible, like depending on like what if-defs you toggle at the beginning. So if you have it, say, on a Linux system, you can't use it in your game unless it was compiled against that copy of libpng on that Linux system, because you probably didn't use the same set of if-defs when you built your game. So if you use that libpng, your game's going to crash, and it's going to crash in weird ways. libjpeg uses set jump, so they're just fucking evil. So don't use those three libraries. They're all very good, and frankly, just about every game you've ever played on any platform probably uses them, but somewhere some game developer in the middle of the night wrung their hands and went, oh, why is this not working? And, you know, they should have read this slide right here. All right. Fortunately, I have a solution for you, and his name is Sean Barrett. There are a bunch of libraries called stb underscore something, stb underscore image, stb underscore Vorbis. He wrote a Vorbis decomposer, if you like. Sean Barrett's a ninja. He works for Rad Game Tools, but one of his agreements with them is that when he writes something awesome and generally useful, he gets to put it under the public domain. Rad Game Tools doesn't own it. Rad Game Tools makes a lot of expensive but useful software for game development, but you know, just smaller things like here's a zlib decompressor I wrote. It's on his website for free, nothings.org. You know, here's something that does JPEGs and PNGs and bitmaps and this and that and the other thing, and it's public domain, blah, blah, blah. All of his stuff is either one C file or one header file that you compile as C. So you can drop it in there and just go and not have to screw around with like build configuration options and stuff like that. Nothings.org. A lot of weird and interesting things on that website, but you can find these projects too. That's his personal website. Also, there's something on Google Code I discovered about a week ago, which I fell in love with, called MiniZ, which is zlib in 300 lines of C code. And you can literally just cut and paste it. It's also public domain, much like Sean Barrett's stuff. In fact, it was inspired by Sean Barrett's stuff. And it's slightly faster than zlib. It compresses slightly better than zlib. It's fully compatible with zlib. In fact, it even has the same API. So you can take zlib out of your project and cut and paste these 300 lines in there and call it a day. So I thumbs up to that. I like that a lot. All right, let's talk about networking for a moment. I have a project that, well, I don't have a project. There's a project called eNet. Has anyone heard of this? No. This doesn't get a lot of play, but it should because it's awesome. Has anyone in here ever had to do network programming? I don't mean like you wrote a PHP thing that runs on Apache. I mean like actual network programming. Like this computer has to talk to this one, but what happens when this one gets unplugged unexpectedly? Okay, you're all sitting in the middle of the room shivering. I see you all there because you know what this is like. It's awful. For those of you that take the internet for granted, there's a level of networking that's mostly used in video games called UDP, which is unreliable packets. You send a packet, and it may not get there, and you'll never know it didn't get there. And you may send a packet and another packet, and they may not get there in the same order you sent them. And you know, it's kind of awful if you have to work at that level, and most games do to their own misery. eNet works, it builds on top of UDP. Networking is hard, by the way. It builds on top of UDP, and it gives you two things. It gives you reliable streams, which are cool. So you can say, which happens to, by the way, turn out a little faster than TCP. Also, unlike TCP streams, which are reliable, they can also block until that reliable stream is fully there. Whereas eNet can handle that. You can split one stream up into multiple channels and say, well, I'm still waiting on this guy, but there's 3 other people still talking to me that I can still get data from in the meantime. So it can also send unreliable packets, and it puts in it increments the packet's ID on each one. So if they get there in the wrong order, or one gets dropped and the next one gets there, it knows what to do with that and it handles that gracefully. Also, a problem with UDP is there's a maximum size to a single packet you can send over the internet. This thing's smart enough to break those big data sets up into multiple packets and make it look like one packet when all of it gets over the internet to your machine. It's really, really nice. It solves a lot of problems. No one should be writing to the UDP level directly anymore. And this project's probably about 10 years old now. It actually comes out of a game engine called Cube, which we'll talk about extremely briefly later on. But if you ever want to do low-level programming, video game or low-level networking, video game or otherwise, you should probably look at this if you're building a protocol from scratch. It's pretty cool. So I want to talk about Mojo Shader, which, oh, hang on a second, blatant self-promotion. This is another project that I built. For those of you that, question? No? Okay. For those of you that have ever had to work with Direct3D shaders and also work with OpenGL shaders, there's a problem. They're not compatible. So you literally end up writing your shaders, which are programs that run on the video card, you literally end up writing those programs twice. And they're mostly the same, but not the same enough, and it's frustrating. It's exceedingly frustrating. And more to the point, as a game developer that mostly works on porting Windows games to Linux and Windows games that only use Direct3D, I have to deal with not just getting the game running, but all the video programs, all the programs that run on the GPU running too. So I built this for a game called Unreal Tournament 3, which shipped and was a wild success on Linux. That's not true. Anyway, but the fundamental problem is that you had all the mods in the game. There were the shaders that shipped with the game, and then you had mods to the game you could do, and you could put your own shaders in there. So even if I ported every single Direct3D shader to OpenGL's languages, I couldn't deal with mods. They just simply would not work because there would be shaders coming in that the game didn't know how to handle that were written specifically for Direct3D. So what Mojo Shader does is take the compiled version of the Direct3D shader, parses it, figures out what the hell it's doing, and then writes a GLSL version of it. Or if you have an older computer, it can write ARB programs too, which I won't get into the details of it. If this is boring you, then just zone out for until the next slide. If you're shipping shaders that are assembly language, we can assemble them on the fly and turn them right into OpenGL code. And we're working on a full HLSL compiler. So if you're writing the C-level language of shaders, you're going to be able to eventually just drop that right onto your Linux box and go right on OpenGL and not know the difference. It's just going straight ahead. There is another project called CG, which NVIDIA wrote, which is kind of like a portable version of HLSL, and it's so bad to use that it was actually easier to spend a year writing my own thing from scratch. So you're welcome. This is cool if you're doing 3D game development. You're doing big, complex video stuff instead of simple like sprites on the screen. Okay, for those that tuned out, hey, I thought you said this was about tools. All these have been game libraries so far, and I know people think tools, they think things they can run, and tools, things you can hold and wield. So I want to talk about some things really quickly that are, tools instead of just game libraries. First one is Google BreakPad. Does anyone use this? If you use Firefox, you have used this and you don't know it, because Firefox crashes all the time. Am I right? A lot of Chrome users in this room. Okay, good. Google BreakPad. Basically, there is a small part of it that actually runs in your program that when you crash, your program goes into a signal handler because you've stepped on memory or something like that. The program's actually crashing. Google BreakPad steps in and writes out a crash report. And then they give you tools to take those crash reports collectively and organize them and see where your crashes are coming from. And Google did this because they have programs in the field like, say, Google Earth, where there's millions of people using it. And unlike things that run on their web servers, like if Google.com segfaults or whatever Google.com does when it goes down, that's on their machines. They can pull that crash information off very easily and report that and collect it and organize it. They can't do that so well when it's like some guy running Windows 98 and has 15 viruses and some old version of Internet Explorer that's causing the system to show random LOL cats all day. They can't get that information from these people, so they built this thing called Google BreakPad, which helps them collect that, and then on their servers they can process it and say, well, this build is pretty good. We've only had 15 crashes, and they're all in Oklahoma, things like that. I mentioned Firefox because Mozilla uses this also, just to give you an idea of how well this scales, but I would argue this is also really useful if you're writing a tiny little game that nobody's ever heard of yet. This will give you a chance to collect data because the fact of the matter is end users do not report crashes for the most part. Mostly they go on forums and complain about your game. So, and they won't even post the crash dump there. So, so rather than get bad press, it's good to be able to see where people are unhappy with your work and correct it before there's a problem. Whether you're open source or whether you're writing Gears of War 12, this is all important the same way. Valgrind. That's pronounced Valgrind, by the way. I've been pronouncing it wrong for many years. How many people have used this? This thing will save your life. I want you all to raise your hands next year if I'm back. Valgrind, basically what it does is it runs your program under a virtual machine very slowly, but it runs it. and it checks every single memory access you do. So if you write to a piece of memory you haven't initialized, it tells you immediately where. It tells you exactly how you got to that point. It tells you where that memory came from. Oh, you freed this memory over here, but now you're writing to it again. It can tell you when you've blown your stack. It can tell you when you're writing to stuff you haven't initialized. It can tell you when you're taking a branch, like an if statement, from an uninitialized variable. It's incredibly useful, and it tells you exactly where in the program you did this and how you got there. I remember when Valgrind first came out, they started pushing things like KDE through it, and you would be amazed at how many bugs, if you go and just look on Google for like, I haven't done this, I don't know, but if you look on Google for like Valgrind fix or something like that, thousands of commits across thousands of open source projects as people start going, oh shit, I didn't even know there was a bug there. And those are good. You fix them then, because someday you're going to know there's a bug there and you're going to be real mad about it. So it's better to find them with Valgrind ahead of time. Now, the downside of Valgrind is very slow. Their estimate at the time is that you would run something about 16 times slower than real time, which isn't a big deal if you're doing, say, Microsoft Word. You can hit a key and wait until, the word processor punches up the next letter. But it can be a little frustrating if you're writing a game and your frame rate's so low that you can't really play it to get to the bug, but I found perseverance is worth it in this. If you can find some way to automate it enough that it will trigger that bug under Valgrind, your life is much better. And this is good advice. If you have a program you have written in native code, if it's C or C++, your ass is downloading Valgrind tonight. It doesn't matter whether you're writing video games or you're writing GTK apps or you're writing command line tools. You need to run it under Valgrind. Your life is going to improve by an order of magnitude by tomorrow. I guarantee it. GDB 7. Anyone heard of GDB? Yeah. Okay, good. Half the room. I know where the C programmers are now. GDB is the debugger, the standard Linux debugger and other system debugger. It's always been a good debugger if you like the command line. It's not so good if you need, Visual Studio's graphic interface, but GDB 7 is the new version of it. They're up to like 7.4 or something right now. This added a very important feature called reverse debugging. Has anyone heard of this before? Reverse debugging is debugging for TiVo. You run your program until it crashes, and then you start stepping backwards, which is different. The standard way of debugging is you know roughly where the crash is, and you try to stop before it, and then slowly inch up until you see why it's crashing. Whereas here, this just flips it on its head. You run until you crash, and then you roll your program backwards line by line until you figure out where it went wrong that caused your crash. This adds some slowness also in the same way Valgrind does, and it's still a work in progress. They're still improving it. There's a commercial version. There's a commercial equivalent of this called UndoDB, which I think is a little ahead of it if you have $300 to drop. Give it another year, though, and that won't be true. You'd be a sucker to pay for it a year from now. But reverse debugging is the next big thing in debugging, and GDB is kind of leading the way in that with free software, which is beyond awesome. So you should be using that if you're a C programmer or a C++ programmer, because everyone's got that bug they can't reproduce. Now you can reproduce it, because it triggers, and then you step back and see exactly why in a frozen state, which is cool. All right, Clang. Who uses Clang? Anyone here a Mac programmer? You're using Clang whether you know it or not, or you will be soon if you're not. Clang is a C compiler and a C++ compiler, much like GCC is. This is a different one. It's open source. It's under a BSD license. The guy that wrote it works for Apple. He's paid by Apple to work on Clang full time. He used to work for Microsoft as an intern at their research labs working on Visual Studio. So he has a rich, if not twisted, history in compiler development. He's incredibly smart. He has an incredibly smart team working for him. And they're kind of slowly starting to push the state of the art in compiler development. Specifically, Clang has a feature that GCC doesn't have. It makes it worth looking at, called static analysis. And static analysis is going to be the next big thing. That's when you compile your program and the compiler tells you where your bugs are before it compiles the code. It'll say, hey, and you see a little bit of this even in regular compilers, hey, we notice you're using this variable, you've never initialized it. Whereas Clang's more like, you're using this variable which came from over here, which couldn't possibly be true if you hit this part, and it's very complex, and I have not yet seen a project that didn't come up with hundreds of subtle bugs they didn't know about until they ran it through Clang. As an example, we ran SDL, which I mentioned at the beginning of this talk, through it, and found 173 errors in something that was coming up with, compiled with Dashwall, which is all the compiler errors. And we thought we had written just code that like the angels wept while we were coding this. And then we ran it through Clang and it said, here's 173 places you straight up fucked up. And every one of them was a legitimate bug. We just didn't know about it. Having done that and then pushed it through a few other projects because that piqued my interest, and just other open source things, I just have kind of come to the conclusion that it's kind of a miracle the computers boot at all after seeing what Clang shows up. So, you have a question? Clang has spent an enormous amount of effort being GCC compatible. The command line switches are largely the same. The GNU extensions to C that are in GCC are available in Clang. FreeBSD is compiling their entire system with Clang now. So almost all the open source stuff you use, which would also ship on FreeBSD, also in there. My understanding is someone has the Linux kernel building with it, but not booting, but I checked that like a year ago. That's probably working now. So largely painless, but also, this is the other thing that's notable about Clang, much, much faster than GCC. I've seen people that are shipping programs and games on GCC for iOS, at least, because that's really where we're using Clang right now. They're shipping it with GCC, but when they're doing development, they're building with Clang because it compiles 2 or 3 times as fast. So it's worth looking at. We'll have URLs for all this stuff on the website. If you're using a Mac system of some sort, if you're using a Mac or you're using iOS, Clang is the default compiler they're moving to. GCC is still available. It uses Clang's backend behind GCC. It only uses GCC to parse the code, but the actual generation of binaries is done by the same thing Clang uses on Apple's stuff. And eventually they're going to use Clang, which is the front end. So you should be looking at that. Even if you don't switch to it, you should definitely be looking at it. It will find bugs for you. And you'll cry and not tell your friends that you did this, but you know, your code will be that much better. You'll be like, I noticed this in the code, you'll say in your commit log. I don't know anything about Blender, but I was told that if I didn't mention it, that I would be wrong. The guy from Media Goblin likes it. Okay, good. Blender, among other things, is a 3D modeling toolkit. It's apparently incredibly hard to use, but also incredibly powerful. That's all I know about it. But if you don't want to pay for Maya, which is incredibly expensive, Blender should be the first thing you look at, because it's incredibly free. Getting Mercurial. Is anyone here using Subversion? Is anyone here using CVS? You need a new job, dude. Quit. You quit today. Welcome to the future. Distributed version control will change your life, even if it's just you working on the project. If it's you in your garage and nobody else is there, this is still beneficial to you. And I don't really have time to get into why, but it's kind of like coming to Jesus. It's really amazing what it can do. Nobody should be using Subversion at this point. If you're still using it, you get a pass for another 6 months, but that's it. After that, you need to be using Mercurial. The only thing Subversion used to be able, or Git, the only thing Subversion used to be able to do better than Mercurial, and I've seen game teams that are using Git or Mercurial distributed version control for their source code, but their game assets are still in Subversion or Perforce or something like that because they're not good for large binary files. But there's an extension of Mercurial that's now shipping with Mercurial called the Large Files extension, which says just for these big binary blobs like game maps and stuff that you don't care about, you're not going to diff them. If you edit them, you're only going to do it to put a new version in there. You're never going to care about the older version. It'll make Mercurial work like Subversion. It'll have a central server of big binary files, and the rest you get all the distributed goodness for. And you can still go back to old versions, but it pulls them from the server as it needs them. But the rest of the stuff, you're on an airplane, you want to make a fix on your laptop, you can do it. There's a million benefits to this, and I can talk for 3 or 4 hours about this, and I won't. Do you have a question? Large files, one word. Yes, in fact, the Unity people wrote that extension for Mercurial. They're big fans of Mercurial at Unity. But you should, whether you're doing games or not, you need to be using one of these two things. And a year or two from now, I might be up here saying you need to use this one thing. And I don't know which it's going to be, because they're both incredibly good and competitive and improving upon each other all the time. But if I were to point at this slide and it says Subversion, you're in the wrong talk. You need to be moving to one of these right now. And if you're not using source control at all, you need to be using one of these right now. So you're laughing because you all had that job at some point, didn't you? Uh-huh. This guy still has it. So, anyone using SourceSafe? Anyone? Okay, good. All right, so enough about that. Since we're talking about tools, what about the whole package? Because I've only talked about bits and pieces that help you build your game from scratch. And I got to be just full disclosure, I don't have a lot of experience with any of these things, but I want to talk about full game engines that are open source. There's IO Quake and IO Doom 3, which are both, id Software released the source code to their games, Quake 3 and Doom 3, and my site and mostly other people and not me have picked those up and started working on them. The IO stands for Iculus.org, but that was just because I was hosting it. They're really not my projects for the most part. But if you want to start on a solid foundation, I mean, Quake 3 sold hundreds of thousands of units, so you know that stuff works. And these projects have basically said, we don't really want to add much to the game, we just want to port and stabilize what's there and add simple features that don't change gameplay. Like we added voice over IP support to Quake 3, and we added OpenAL so that you could get richer audio out of it, but you're still playing Quake 3. And then other people have taken that. Like there's a game called Urban Terror, which took IO Quake 3, ripped out all the Quake 3 specific parts, and built a whole new game on top of that engine. And that's really what we were hoping for there. Doom 3, IO Doom 3 is just starting. We haven't, I don't even know if we made a commit to it yet, because they just released that a couple of months ago, and we've all been very busy. I've been busy with this person right here. But I might have another baby picture after this, I'm not going to lie to you. Okay, so, so Ogre is another 3D one, Crystal Space, Cube, which is now named Sauerbraten, is another one. And these are all 3D engines. They're all meant to make first-person shooters or things like that. HDE I put up here, it's a simple 2D engine. It will use OpenGL and Direct3D to give you accelerated video, but expects that you're putting flat 2D things on the screen. So if you want to make a simple platformer like Super Mario, or something like that, HDE might be a good first step. That has been ported to Unix. There's a link there. So it runs on Mac and Linux, and we've shipped games on it for the Humble Bundle. Among other things. And so, if you just want a whole package, you want to start and say, I'm more interested in building a game than building a game engine, it might be worthwhile to pick up one of these, or probably several others I didn't list here, and focus on what's important to you. I've always been more of a plumbing person, so I like the lower level stuff, but this is all very high level. And of course there's commercial ones, but that's a different talk. Like Unity's very good, but gotta pay for it. Anyway, wow, this is early. Okay, so the baby picture says I'm at the end of my talk. Cool like daddy. All right, so that's all, folks. If you have any, hire me. If anyone's looking to have stuff ported to Linux or Mac OS or some weird platform no one's ever heard of, I can be bought. So feel free to send me a message at any of those things, Twitter or Google+, or I have a Facebook account, but fuck you if you're using Facebook. Thank you. That's the applause line. Oh, good. Okay. But that Iculus.org/flourish, if you go there, links to everything I talked about in this talk are there, and videos of talks I gave at a previous conference, and the video from this, when they post it, will be there too. Because this hasn't been too embarrassing, I think. Okay, questions. I see this guy here. Yes? Well, that's a good question. The intro to Flourish, I tweeted about this and got retweets, and that's always embarrassing, but the poor guy who did the intro said this might be the year of the Linux desktop, and I laughed out loud. Sorry. It's possible that your next computer won't be something that runs, Crisis 12. It won't be a desktop. It's going to look more like this, or it's going to look like a web browser. In fact, how many of you have seen the video games that they're doing in Google Chrome with native client? The Bastion is one of the ones that just blew me away, that you have this full OpenGL accelerated game running in a web browser, running native code. It's written in C or C++ or something, and it's astonishing what they're doing there. Will HTML5 take over? It depends on the game. I don't know the answer to that. I think there's definitely going to be a market for it. I think there's already a market for it. I don't think it will be all of it. I think we're always going to have a need for native code and need for low-level stuff that you're just not going to be able to get away with on the web. And if Angry Birds ask me what my location is, I'm going to punch it in the face. It's like certain things I don't want in my web browser. I just want to run the game on my computer and be done with it, or on my phone or whatever like that. So I don't know if that answers your question. I think it's promising. I don't think it will take over. I think it will coexist. Any other questions? Anything? Yes? Only 10 years. Yeah. So.
I kind of got into started working on the IO Doom 3 project and eventually get an idea of how to use SDL because I like to start contributing to it. What do you need to know and what kind of skill level do you need to get it to start contributing to that?
To contribute to SDL? It depends. Some of it's incredibly complicated and low level so that end users don't have to end developers don't have to deal with that. We hide all that complexity in SDL. Some of it's a little simpler. We certainly have bugs to fix right now that are, anyone I think could jump in there. There's platform support too that we haven't, our Android port took a long time because we didn't have an Android device for a long time. It just was not our area of expertise. We have them now, it's okay, don't get nervous. You know, some of it's hard, some of it's easier. There's a lot of things we would love to throw out autoconfig and move to CMake, and we need a ninja to do that, and just, it's not a CMake ninja, which is different than a programming ninja. So there's a lot of areas in there, and it depends. It tends to be pretty low level, though, depending on what you're looking to do. So I don't know. Any other questions? Anything? Yes? CVS guy. Sorry. No, I'm genuinely sorry. I'm telling you, you got to get out of that job. I'm sorry, what was your question? I'm just... I don't know anything about 0MQ. I don't know. ENet and 0MQ. Well, okay. Without knowing anything about it, my short answer would be if it uses TCP, it's unusable, is my basic answer. And another one I think is higher level is Google protocol buffers. I don't know if anyone's seen that. Also interesting, not useful for game development unless you can push it over a UDP packet. Because as much as network developers gripe that you can lose a packet, that's also a blessing because you don't want this thing stalling until you get that data. You need to be able to recover from that and move on and say, we lost that, but we know where we are and we're resyncing and we're carrying on. It makes things hard, and you have to, it's like multi-threading, and you have to think on a different level, but there's a reason for it. It's intentionally hard because it needs to be complex. Okay, anyone else? Anyone? Yes?
Okay, I was going to bring this up, you mentioned it. Can you tell us what happened with Unreal Tournament 3? Because like, I saw, you haven't said anything about it in a long time. I just was very curious what actually happened.
You're asking me if I can tell you anything about it?
Yeah, if you can't, I understand.
Can you keep a secret? What's that?
You're on video.
Oh, I guess you can't then. Okay, so, all right. Any other questions? Yes? I don't think that makes you a douchebag. Okay. Well, that, okay. I've heard that, yeah. Yeah. Okay. See, here's the problem is I don't consider that a benefit. I mean, as a programmer, that sounds awesome. As somebody that would be drawing 3D models, I'd be like, why is this showing me Python anything? Okay, that's fine. Yeah. Okay, fair enough. For those, I don't know if anyone could hear that without the mic. What he was saying is that the nice thing about Blender is that it's either built on Python or it's got a Python API, something like that. Okay, so basically you can interface it, you can write Python code to interface with Blender, and that makes it incredibly flexible and powerful and generically awesome. From a tool standpoint, I've heard a lot of people that, this is the best comparison I can give, is that when you talk to game artists, they talk about the GIMP versus Photoshop the same way they talk about Blender versus Maya, whereas... Yeah. Well, and the beautiful thing about open source is if you don't like something, you can just roll your sleeves up and make it better, which I know is a really glib statement, but you can. I mean, if Maya has a bug, hey, sorry, buddy. So, and that, by default, that's always a better solution. But if I give this talk next year, I'd like to say the Blender is awesome. But my consensus that I've gotten from talking to other people is that it needs a lot of work still. But I don't think that makes you a douchebag. I say, you know, good for you. Go out there and make it better, you know. Okay, any questions? Anything else? Anything? Yes, sir. What platform are you on? Okay. Our experience has been we do have bugs, and that is a definite limitation that SDL 1.2 on most platforms, when you resize a window, you lose your OpenGL context, which means that if the program didn't know this, they're going to keep drawing, but none of their OpenGL state's there anymore. More importantly, none of their textures are there anymore. So you might get anything from losing, like you still have a 3D world, but all the textures are gone off of it, to just it's not drawing anything because there's some basic state that's been lost. That's something we have fixed in SDL2. The other problem we have is that we can't ever account for shitty drivers. And you find this a lot with Linux audio too, by the way. And we find this a lot with video on Windows, where it's like, well, it's some random third-party video card with drivers built by the lowest bidders, and some of that we can't account for. Some of it is actually bugs in SDL, and some are architectural things we've improved on. So I would say it's getting better. I can't tell you for certain with your specific problem, but I apologize for it. It's probably Sam's fault. Okay, any other questions? I think I'm about to get the time's up. I'm hanging around if anyone has any questions. Thank you very much.